Comets are often called dirty snowballs, and they're essentially ancient relics from the dawn of our solar system, made of ice, dust, and rock. As they get closer to the sun, the heat causes them to release gas and dust, creating that beautiful glowing coma and the iconic tail we all love to see. Comet 3 IATLAS, discovered by the Asteroid Terrestrial Limpact Last Alert System, or ATLAS, was a particularly fascinating one. It was an interstellar object, meaning it came from another star system, passing through ours on a one-of-a-kind journey. When it was first spotted, it was just a faint blip, but it brightened incredibly quickly, getting thousands of times brighter in just a matter of weeks. This rapid brightening got everyone really excited, thinking we were in for a spectacular celestial show. But then, something unexpected happened. It started to fade and eventually broke apart. This is a pretty common fate for comets, especially those making their first fiery pass close to the sun. The intense solar radiation and gravitational forces can be too much for their fragile structures to handle. But here's where we get into the really cool what-if scenario. What if Comet 3 I Atlas, or a similar interstellar object, wasn't just brightening in the usual way? What if it was growing? Now, hold on. I know what you're thinking. How can a comet grow? Doesn't the sun just melt it away? And you're right, that's the conventional understanding. But let's explore a fascinating, albeit speculative, idea. The universe is not an empty void. The space between stars, the interstellar medium, is filled with a thin soup of gas and dust. It's incredibly diffuse, but it's there. Imagine an object traveling through this medium for millions or even billions of years. Could it accumulate material? Think of it like a tiny snowball rolling through a field of very, very fine powder over an immense timescale. Could it slowly gather a frost of interstellar ice and dust on its surface? This process is known as accretion. We see it happening on a massive scale in the formation of stars and planets, where huge clouds of gas and dust collapse under gravity. But could it happen on the scale of a single comet? If a comet were to accrete material, its journey through interstellar space would be one of growth, not decay. It would arrive in our solar system bigger and more massive than when it left its home star. So, when 3I Atlas started brightening so dramatically, maybe it wasn't just the sun boiling off its surface layers. What if that rapid brightening was a sign of something else? Perhaps the new material it had collected on its surface was much more volatile than its core. This freshly accreted frost of exotic ices would vaporize at a much faster rate, causing that incredible surge in brightness we observed. This would be like having a firework with an extra powerful, fast-burning fuse. The outer layer goes up in a brilliant flash, far more intensely than the main charge. The initial spectacular brightening of 3I Atlas could have been this accreted layer vaporizing, which would also explain why it seemed to fizzle out so quickly. Once that highly volatile outer shell was gone, the comet's activity would drop back to what we'd expect from its older, more stable core material. The fragmentation could still happen as a result result of the Sun's heat and gravity acting on this no-exposed core. So, why is this idea so exciting? If comets can grow as they travel between stars, it changes how we think about the transfer of materials across the galaxy. These interstellar visitors wouldn't just be messengers from other solar systems. They'd be collectors, gathering samples from the vast stretches of space they traverse. An object that originated from one star system could arrive at another, carrying with it dust and gas from countless nebulae and stellar regions it passed through along the way. It would be a cosmic time capsule, not just of its origin, but of its entire journey. Studying the composition of such an object would be like reading a galactic history book. We could potentially learn about the chemical makeup of different regions of the vecid Milky Way without ever having to send a probe there. For example, if we found elements or isotopes on an interstellar comet that are rare in our solar system but known to be produced by a specific type of star, we could trace its path back through regions where those stars are common. It would open up a whole new field of galactic archaeology. Furthermore, this has profound implications for the concept of panspermia, the idea that life, or at least its building blocks, can be transported between star systems. But we already know that comets contain complex organic molecules, the very ingredients for life. If these comets are also growing, collecting more material as they travel, they could be picking up even more of these crucial compounds from the interstellar medium. This would make them even better vehicles for seeding life across the galaxy. A growing comet is a more robust, better protected vessel for carrying delicate organic molecules on their long, cold journey through space. Of course, this is all highly theoretical. The density of the interstellar medium is extremely low, and many scientists would argue that any accretion would be negligible compared to the erosion that happens even from things like cosmic rays. The forces of erosion are constant, while accretion would be a painfully slow process. Proving this one way or another would be incredibly difficult. We would need to get up close and personal with an interstellar comet. We'd need to land on it, drill into its surface, and analyze its layers. Like geologists studying ice cores here on Earth to learn about past climates. The different layers of a growing comet would tell a story. The outermost layer would represent the most recently collected interstellar material, while deeper layers would correspond to earlier parts of its journey, and the core would be the pristine material from its home star system. The European Space Agency's Comet Interceptor mission, planned for launch in the late 2020s, is designed to do just that. Visit a long period or even interstellar comet. A mission like this could be the key to unlocking this very secret. So, while Comet 3I Atlas may have come and gone, it left us with some incredible questions. It pushed us to think outside the box and consider possibilities that challenge our standard models. Was its rapid brightening simply the death throes of a fragile visitor from another star? Or were we witnessing the spectacular shedding of a coat it had grown over millions of years of interstellar travel? We may not have the answer yet, but the possibility that these cosmic wanderers are growing, collecting stories from across the galaxy, is a truly mind-bending thought. It reminds us that the universe is always more complex and more wonderful than we can imagine. What do you guys think? Could comets actually grow in interstellar space? Let me know your thoughts down in the comments. It's a wild idea, but that's what makes space exploration so fun. Thanks so much for watching. If you enjoyed this cosmic journey, don't forget to hit that like button and subscribe for more adventures into the unknown. We'll see you in the next video.